Tutorial sheet 1, question 10. So we're given two functions, x of n and z of n, where x of n is equal to 1, minus 1 and 2 for the values of n equals 0, 1 and 2, and z of n is 1, 2, 3 and minus 1 for when n is minus 1, 0, 1 and 2. And the question asks us to compute and sketch y of n, which is equal to x of n convolved with z of n. So we of course have to recall the convolution integral, and in this case we're using, this is a discrete function, these are two discrete functions. So in this case we have a sum of x of k times z of n minus k. So that's the convolution sum in this case. Now what I've done, I've already drawn out the table that we need to do this, and I've filled in the values of x of k. So the first stage is that you replace n with k, which I've done here, and I've written this out. So we have 1, minus 1 and 2 as we were told in that first function. The next function, z, well, this is the one that we're going to have in here, and this is the one which we're going to flip. So we've got to take our z of n, replace n with k, and then flip it onto the about the y equals 0 axis, and then we're going to shift it to, first of all, n is equal to minus 1. This is so that this is the first value of n in which these the two functions actually cross over. So if I do that, what I get is 1, 2, 3, minus 1. So you can see that these two functions are flipped over, so that 1 goes to there, 2, 3 and minus 1, and then we've shifted it to n minus 1. And then what we need to do is carry out the convolution, which says for all values of k, I should have put from k is equal to minus infinity to infinity, we have to do this multiplication and then summation. So we can see here for times where n is where k is less than 0, the multiplication is 2 times, well, this is nothing in here, so there's nothing happening, and the only output is when k is equal to 0, so you've got 1 times 1 is equal to 1. So the output there is simply 1. And then we gradually shift this function to the right, so that what we have here is that n is equal to 0. We have that function, and here again we have to go for each value of k, multiplying x of k with z of n minus k. So we've got 1 multiplied by 2 plus minus 1 multiplied by 1, which is of course minus 1. So the total there is still 1. And then again we shift this function to the right, and again we multiply all the non-zero elements. So we have 1 multiplied by 3, which is 3, minus 1 multiplied by 2, which is minus 2, and 2 multiplied by 1, which is 2. So the output there is 3. We carry on these steps of shifting the function across. Now in this case the positive 1 is being multiplied by 0, so that no longer needs to be taken into account. So we have 1 multiplied by minus 1, minus 1 multiplied by 3, and 2 multiplied by 2. And of course that is 0. If we shift it across again, now the back of the function is now passed beyond 0, so we're now looking at just these two columns. So minus 1 multiplied by minus 1 is 1, and 2 multiplied by 3 is 6. So the total is 7. If we shift it across one more, now here we only have one non-zero component, which is 2 multiplied by minus 1, which is minus 2. And if we move it across one more, well, the function disappears and there are no longer any non-zero components, so it goes to 0 at that point. So these are the steps that we have to carry out to get us the output y of n. And of course the question also asks us to sketch a graph of this. So what we're going to need is a graph of y of n versus n, and we're going to need to go from, if I bring this back, we're going to have scales from minus 1 to 5. And we also, if we bring this back, we need to look at what the scales are for y of n. Well, the maximum is 7 and the minimum is minus 2. And then we simply go step by step, plotting the points. So when n is minus 1, we had a value of 1. When n is 0, we also have a value of 1. When n is 1, we have a value of 3. N was 2, we had a value of 0. When n is 3, we had a value of 7. When n is 4, we had a value of minus 2. And then 5, we go back to 0 again. So that is the output graph that we are after.